Hello, everyone, and thank you for joining us today. Welcome to our first webinar in our new series hosted by our solutions engineering team. Today, we will be discussing provisioning VMs to public clouds with HashiCorp Terraform. I'd like to introduce you to our presenter today, Roger Berlin. He's our senior solutions engineer at HashiCorp. Roger will walk through the basics of Terraform and then go into an in-depth demo. John Benson, our global head of solutions engineering, will then answer some questions from all of you at the end. I also want to note that this webinar is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. With that, let's go ahead and get started. Take it away, Roger.
Okay, great. I think you need to let me share my screen or make me presenter maybe. All right, great, thank you. Okay, so thank you everybody for joining. I think you'll find this presentation and demo especially pretty interesting. Let me start with some slides. I know a lot of people don't like looking at slides, but I think it's good to level set. You know, in a webinar like this, it's hard to know exactly how much different people know about things, you know, about Terraform. So it's good to level set. But what I'm going to be doing today is giving an overview of Terraform, as Amanda mentioned. And then I will be doing a demo that will show provisioning of VMs to the three major clouds that you see listed here. And I'm also going to focus on something on how Terraform together with Sentinel can provide governance to the provisioning to make sure that the infrastructure being provisioned by Terraform aligns, it is enforcing your policies about what kind of things you want. So this is what regions to deploy to, the sizes of VMs, and things like that. So let's try that again. There we go. What happened there? That went to the very end of the, that's strange. There we, no? Hold on one second, guys, I'm sorry. Oh, you know what, that's why. How did that, oh, I was on the wrong slide. I'm so sorry. Okay, so this is the slide we wanted to start with. And Terraform, you know, overall HashiCorp as a company is focused on helping customers provision, secure, connect, and run any infrastructure for any application. And you see my name listed there again. I'm a senior solutions engineer at HashiCorp. So the agenda for today is to focus on, first of all, the HashiCorp product suite, just a little bit, challenges that customers face and that we address, product design principles, and then we'll talk about Terraform. We'll talk about the open source version first, but then how Terraform Enterprise, the commercial implementation of Terraform, how that addresses organizational challenges, including collaboration and governance. And then we'll talk a little bit about the ecosystem, the use cases, and customers, and then I'll do the demo that I just mentioned. And then John Benson, as Amanda mentioned, will be answering some of your questions that you've submitted through chat. Okay, so first of all, the HashiCorp open source suite consists of the 4 products that you see here, and these align to the things I had on that very first slide, which is that Terraform helps customers provision their infrastructure. That's especially typically done by operations teams. Vault helps security teams secure infrastructure and applications, and Nomad helps customers run their applications. It's essentially a job scheduler. And then Console provides service discovery and health service monitoring to actually connect applications together to enable, you know, either legacy apps and especially microservices to find each other. It also acts as a key value store, by the way, distributed key value store. Now, those are the open source products. We can then switch over to the other side here where we have the corresponding enterprise products, you know, and these products add in additional capabilities that meet the needs of teams, in particular, collaboration between members of teams, and then governance so that organizations can govern what one or more teams are doing. And of course, I forgot to mention on the left side of the screen that the open source products are aimed at meeting the needs of individuals or small numbers of individuals. So what are some of the challenges of provisioning in the cloud? The challenges include scale. Obviously, when you're provisioning hundreds or thousands of VMs and the associated infrastructure, that's a much more complicated problem than if you're, you know, just doing, you know, 10 or 20. And when you're doing 10, maybe you can just do everything through the AWS UI or the Azure portal. You can use web-based UIs to provision things in a manual fashion. But when you're talking about large scale, you need something that will essentially codify how you're doing that and make sure that things are repeatable. Heterogeneity is another important problem in the cloud, because most customers that we speak to actually are using more than one cloud. Often they have one cloud that might be the dominant one, but sometimes they're using two, sometimes they might use three. And then there's dependencies. When you're provisioning some resources, you might provision a VM and then want to provision a DNS for one of those VMs and map it to the IP of the VM. And so you need to be able to provision different resources, the low-level infrastructure, but also higher-level things, or things that are dependent upon that infrastructure. And so Terraform does help with all of those things. And in fact, in general, the HashiCorp product suite helps with all of those. What are our design principles? In general, codification is the first one, that if things are codified, and so what, you might have heard the expression infrastructure as code, and that applies to Terraform in particular. So when you have code that's saying what your infrastructure is supposed to be, and you use that code to do the provisioning, instead of using a UI or some manual process, you can then repeat that. And so your infrastructure it's something you can test and then roll out to production. It's repeatable, it's reliable. So this increases operator productivity and gives a more reliable result in terms of the actual deployments. So we do codification with Terraform at that level. We'll also talk, when I talk about Sentinel, our policy enforcement tool, you're going to see that we talk about policy as code, because then your policies are also codified. Workflows, not technology, is the second column here. When we create products, we tend to think about what are the workflows that are important and for which additional tools are needed. And we don't think about just one specific technology. Even if we start out, for instance, when we first started with things like Terraform, in terms of using Terraform for the cloud, I think that AWS was the first one, but we made sure to do things in a way that could then later on expand to support Azure and Google and Alibaba, and VMware, right? So we focus on the workflows, not the technologies. And by focusing on that and making sure the workflows are right, this reduces errors and associated costs, and to allow customers to safely provision and manage their infrastructure. And then finally, our solutions, including Terraform, are open and extensible. So in the case of Terraform, there's the Terraform core, and then there's also providers. And we write some of those providers, but partners create some of those, and customers can create their own providers. So all of our products have a plug-in type architecture, and this protects you against changes in technologies. It protects you against vendor lock-in, and it just makes our solutions overall more adaptable, so that any customer using our solutions can quickly accomplish what they want to accomplish, and have our solutions interact with the technologies that they're using. One more point I'll make is that most of our products, or all of them, have some level, APIs. And in the case of Terraform Enterprise, you're going to see that everything you can do through the UI, you can also do through APIs. And that's important in terms of doing, developing CI/CD pipelines, in which Terraform might be part of that. Okay, this is just a slide showing that we're now, for the rest of this presentation and demo, we'll be focusing on Terraform. And the mission of Terraform is to give a consistent workflow to provision any infrastructure for any application. So those who have used Terraform open source will know that in general, there's two steps of provisioning anything with Terraform. You do the plan, and then you do the apply. So the plan will show you what you're going to provision, and then the apply is what actually does it. And then the other part of this so far is talking about how we're splitting out the core product from the providers. This used to all be part of one open source solution, and if we wanted to make changes to the providers, we had to do a new release of the core product. Now we no longer need to do that. Different providers can be released on their own schedule, so that's very important. And that plan and apply, another point to make about that is that Terraform is actually indicating what the target state should be. So it's not procedural in nature. It's actually indicating that if you say you want to have 10 VMs and you have a plan to do that, and you've run that, and later on you modify the plan to expand to 15 VMs, Terraform will only deploy an additional 5 VMs. It's not going to deploy an extra 15 VMs on top of the 10 that you already had. Okay, so that's an important point. On the left side, what I added in there is you now start to work, and this is kind of still with Terraform open source. You know, at a small scale, you might have one operator who's using Terraform and creating different configurations and then handing off that infrastructure to a developer or two. And one of the things you may not be aware of is we do have a public module registry, and that fosters reuse of Terraform code so that operators, those are actually public modules for the major clouds, so that you can more quickly spin up your infrastructure based on the modules that are there. And so developers and operators can consume those modules. Additionally, you can be storing your Terraform code in a version control system, like GitHub or Bitbucket, and be benefiting from that as well. And then what we add in here is we add in the extensible provider model that I mentioned earlier. So we have providers for the major clouds, but we also have many other providers for various things like Kubernetes and a lot of other things, applications, different kinds of monitoring agents, many different agents. In fact, there's over 70 providers, and there's over 1,000 distinct resources that can be provisioned with Terraform at this time. Those are the ones that we manage and track, not even including things like F5 is listed here. That's not one we've created. That was created by F5 itself. Okay, so let me move on from there. This slide is just kind of focusing on how we allocate different features into the open source versions of our products, Terraform in this case, and 2 levels of the enterprise product. That's the 2 levels are Pro and Premium that you see on the bottom. Essentially, Pro is meant for teams. The open source version, as I said before, is meant for individuals. When you get to a larger team, that's when you would start to benefit from the collaboration capabilities that Pro adds on top of the provisioning capabilities. And then if you have a larger organization consisting of multiple teams, that's where we then add on governance capabilities and of course expanded support. So that's how in general you're going to find that features are allocated or targeted to these different versions of Terraform and our other products as well. It's the same principle. So again, talking about Terraform open source for a minute, if you just have one operator and one developer, you can pretty much do everything and run Terraform on your laptops and be provisioning, and the state is maintained on your laptop most likely, and that's okay. That's very workable. But if you expand to having multiple operators and multiple developers, this becomes more challenging, right? As the team grows, managing this becomes a more complex problem, and that's effectively what Terraform Enterprise addresses. Terraform Enterprise addresses the organizational complexity that comes with having more people involved in the provisioning and more teams. So what are the core things? And you're going to see all this when I do the demo, but one of the first key thing with Terraform Enterprise is that there's integration between Terraform Enterprise and the VCS, the version control systems, right? Including GitHub, GitLab, Bitbucket, etc. And so that means that when you can store your Terraform code, which is important. Just like you want to do version control on your application code, you also want to do version control on your Terraform code. And so you can store that, let's say, in GitHub, and then when you do changes to GitHub, when you do a commit, that will trigger a run in Terraform Enterprise and cause a plan to be done. And then you could also do an apply if you want to do that. So, and there's also, by the way, if you do, we'll see later in the demo that if you do a pull request and a merge, that also triggers activity in Terraform. You deal with runs and state management. So I just mentioned runs, plans, and applies, right? We refer to that collectively as a run, but also state management. So Terraform's actually managing the state for you on a server. And there's actually 2 implementations of Terraform. There's a SaaS-based solution, software as a service, running under a particular URL. That's a public, and that's a multi-tenant shared service, and that's something that customers can use. You can also deploy your own private Terraform Enterprise server. In either case, the server will be managing all the state for these different runs and for what's been done so far. So that's another important benefit of Terraform Enterprise. And then also what we're doing is we're giving organizations governance over their infrastructure. And in particular, that's done through Sentinel. Now, without Sentinel, typically customers, when they have various policies about what they want done, it's not actually being enforced by the software, right? They have spreadsheets, they have Google Docs, Word docs, right? And so it's possible that in this slide, what we're seeing is that Google and AWS are in compliance with your policies, but Azure is not, because there's no mechanism to enforce it. With Sentinel, what we do is we have this notion of creating policies, and those policies are checked between the plan and the apply. So Sentinel, we have our own language for that. And it's a very readable, easy to learn way to create rules, and those rules then have to be enforced. And I should mention, by the way, and we'll see this in the demo, you notice there's enforcement mode. There's 3 enforcement modes for Sentinel: advisory, soft mandatory, and hard mandatory. And I'll get into that more later. So here you see that a run's being done, and we have a green check mark on the plan, and then the policy check is being inserted in between the plan and the apply. And here in this case, we actually can see that Ryan Uber, one of our engineers, has actually overridden the policy check. So there was a soft failure. Soft mandatory policies can be overridden by somebody with the suitable permissions, whereas hard mandatory policies cannot be. And then, as a result of using Sentinel together with Terraform, now you're guaranteed that all of your infrastructure will be in compliance, at least as long as you're provisioning through Terraform. Okay, so pretty much we're getting near the end of the slides here, and I want to leave plenty of time for the demo and for your questions, but this is just illustrating the Terraform ecosystem, including the version control systems that I already mentioned, and then some of the major infrastructure partners, including the 3 that I'll be demoing with today, as well as others. And here are some customers as well. You see there's some big names there, as well as other names. And then finally, we have some use cases. So use cases for Terraform include, essentially everybody using Terraform is essentially doing infrastructure as code, so that they're writing, testing, and provisioning their infrastructure at scale and automating things. Again, I mentioned that Terraform Enterprise has an API, so that allows you to automate provisioning, into Terraform, from Jenkins or from other tools as part of your CI/CD pipeline. And of course, Terraform Enterprise can be used with Packer, our own Packer solution, if you're using Packer to build your AMIs and your VMs. And then we have multi-cloud management as a second use case, providing operators with a consistent workflow to safely provision any infrastructure without losing the full capabilities of each cloud. So again, this gets back to the heterogeneity challenge that I mentioned earlier. And then self-service infrastructure, allowing operators to provide Terraform modules to a larger group of developers who can then run their applications and provision the things that they need with Terraform using those modules. And those modules then will be written in a way to conform to the Sentinel policies. So we're ready for the demo. I hope you guys are too. And this is where I'm now going to go through and do what I mentioned earlier. Okay, so with that, let me minimize that and let me switch over here to, let's start with Terraform. So we're looking at the Terraform UI here, and what we have here is I'm in a particular organization called Cloud Operations, and I have 4 workspaces defined. And I see the most recent status for each of those workspaces. We happen to have done a dry run yesterday, so we did some things yesterday, and we see that there were, 3 of them were in an applied state, and 1 was in a planned error state, which was intentional. And what we see here is I have 1 workspace that's pointing against app in Azure. These are all pointing against GitHub, and I'm going to show you those repositories, but one of them is pointing against a repository to provision Azure VM. 2 of them are actually doing AWS EC2 instances, because I have a dev and a prod instance of that, and then 1 is for Google. Now, I also want to show you some of the organizational settings and how we control things and how we allow teams to work together. You can see here on the team management screen that I have 3 teams: developers, operations, and owners. In the developers team, we have 1 user named Roger Dev. On the operations team, we have 1 user named Roger Ops. By the way, notice also there are API tokens that can be used for scripting and automation purposes that you can create at the team level. And then those team tokens will have the permissions of the teams. And then we have the owners organization. So we see myself and we see John Benson, and we see a few webhooks that have been created. So these are the owners essentially have permissions to do everything within an organization. They're the owners of the organization, they're the super users. The other teams will have different permissions in different workspaces depending upon what you assign. So if I were to go into the GCP, the Google Compute Instance workspace, and look at access, we can see that the operations team has admin privileges and the developers team have read privileges within this workspace. And there's also another level of permission called write permissions. So that's how we control access, and that's how we're enabling the collaboration and the organizational governance at the team level. Okay, so with that, let's do some provisioning. Let me show you first of all what I have for the Google workspace, the GCP compute instance. Notice this is pointing against our Berlin GCP compute instance, and I'm pointing against the dev branch of that. And if we go look at that over in GitHub, we can see that this just has a simple main.tf file. It's quite simple. And what I'm actually doing here is I have some different variables, some Google credentials and GCP project and other things like that. And eventually, a whole bunch of variables. I'm provisioning here's the Google provider being referenced and using those variables. And then I have my Google Compute instance that I'm actually creating, right? That's the Google Compute instance being created, a VM, in other words, and here's the external IP output that I'm going to generate from that. Let's actually go do that. Before I do it, let me just show you the variables. Notice GCP credentials. Those are my Google credentials that I need to provision anything into Google. Note that it's not visible. That's because we have the ability in Terraform Enterprise to mark variables as sensitive, meaning that they're write only. Sorry, they're write only. So you can see them as you're creating them, but after that, nobody can see them. Even I can't see them, and I can't uncheck the box. So we have the Google credentials, which project I'm going to provision into. We can see over here I have my, I'm set to that project, and there's no VM instances currently. And we have this other thing, confirm destroy, just lets me destroy it later. We don't care about that. So let's go ahead and queue the plan. I'm going to queue it from here. And when I do that, it takes me to the runs page, and we can see that a run is pending and is now planning. So we're in the planning state. And while we're doing that, let me show you the policy that's being involved here. So I have 4 different policies here, and this one, these are the Sentinel policies, and this one I have restrict GCP machine type. So what I'm doing here is, this part is because I can have modules. I don't have any in this case, but as a generalized principle, I'm basically looking for VMs across all of my modules. Specifically, sorry, I'm looking for Google Compute Instance VMs across all of my modules, right? I'm looping through all modules, and then I'm returning a list of basically building up a list of all those VMs. I have an array here, a list of what my allowed Google machine types are. I get my machine types, I get my list of VMs, and then I'm basically just going kind of a loop. It's a certain structure going through, and I'm saying for each Google Compute instance, I want to make sure that the machine type is inside that allowed machine types list. Excuse me one second. Okay, so, and then we see finally the main rule says, I have one rule here. Later we'll see that you can combine multiple rules together, but I have my main rule says machine type allowed has to be true. Okay, let's go back to where we were doing the plan, and we can see down here that the plan was successful. We can expand that and see that it's, what it's doing. And for those who have used open source Terraform, you'll see this is just like a typical plan. And we can hide that. And notice we have organization policy soft failed. Let's take a look at the check and see what happened there. So the failed policies will generally, all policies, by the way, in an organization are always tested against all provisioning. But we can see here, restrict GCP machine type Sentinel, that gave a result of false. Well, and then we can go down and see which specific rule. Well, there's only one, but we can see which thing failed there, okay? So everything else is true, so that's fine. So why did that fail? Well, if we go back and look at what I was provisioning here, notice that my machine type here was N1 standard 1. Well, and remember what I was allowing in the Sentinel policy was N1 standard 2 and 4. Well, this one's even cheaper, right? So, okay, if somebody wants to provision something, the whole reason for limiting the instance type probably is to save money, right? So what I'm going to do here is I'm going to override. I'm going to say, the that's even cheaper. I'm going to say override and continue. So remember, this was a soft failure. This was one of the policies that I'm allowed to override. We see my comment showed up, and now I can go ahead and provision that to Google. So now this is going to start doing the apply. So you see how we now have a 3-step process in Terraform Enterprise. We have plan, policy check, and apply. So while that's running, what I'm going to do is I'm going to move on to the Azure workspace. Let's move on to Azure. And if we look here, we see that it's integrated into our Berlin Azure modules test. So I don't need the Google one anymore. We can come here and look at Azure. This one's a little more interesting in that when we look at the main TF here, we're going to see that this is actually using a module. And in fact, it's using a module from our public registry. So I mentioned the registry earlier. And here I have a screen showing our Terraform module registry, the public one. And if I search for Azure, we can see that there's a bunch of different modules already there. And the compute module happens to be the one that I'm using. And for each module in the registry, you're going to have a README that gives an example of how to use it. We're going to see what the inputs are, including whether they're mandatory, required, or optional. Those are the variables that you might have to populate. We have outputs, dependencies, possibly depending on other modules, and resources. What resources are being created. So that's the public registry. And in the case of Azure, what we're doing is we're actually creating that. Now notice I'm creating a Windows, just one Windows VM here in that module. We can see that here, it's Windows Server. Now, if we come back to Terraform and look at my variables, again, I have a Windows DNS prefix, which is a Terraform variable, including my name. And then I have my Azure credentials, my 4 separate credentials that are all invisible, just like before. So we could go ahead and queue this plan. And now this is going to start queuing that. And while we're doing that, let's take a look at the Terraform policy. So that Sentinel policy that we have for Azure. What I have in this case is one that is, again, going to get all the Azure VMs. It looks like the same function. It's a little bit different because it's looking at Azure virtual machines instead of Google Compute instances. And then what I have here is, instead of an array or a list of instance types, I have a list of publishers. So we're saying here that we only want to allow Windows and Red Hat Azure instances. We don't want Ubuntu or other things for whatever reason, right? Somebody might prefer a certain flavor of Linux to be used because you have a support contract maybe with Red Hat. And then what I'm doing is I'm saying the storage image reference .publisher has to be in that list. Okay, so let's see what's happening with our provisioning. We've gotten down to the policy check, and all the policies passed this time because remember I was doing Windows, so that's great. I can just go ahead and confirm this. I could add a comment if I wanted to, but I don't need to. So I've applied that. By the way, if I come over to Google now, notice that we have a VM has now been provisioned. So my provisioning at Google was successful. So that worked. And over here, we'll see that we'll start to have some things showing up. Now I have a Terraform Compute resource group, and that will eventually start to show more things. We're going to get a VM there. So this is Azure starting to create a bunch of things that the VM needs inside that resource group. Okay, so while that's running, let me move on to the first of the 2 AWS instances. And again, by the way, notice that I've been triggering these runs from inside the Terraform Enterprise UI. But later I'll show you how we can do things from GitHub directly. So in this case, I'm going to queue this. Oh, let's take a look at what we have. We have our Berlin AWS EC2 instance. And if we look at that code, what we're going to see is this is like the Google code that I had before. But what I've done here is I'm using a best practice, which is to separate out the variables into their own separate variables file, variables TF. And I have the outputs separated into an outputs file. And then we have our main TF. So the main TF here is very simple. I'm just provisioning a Ubuntu instance. Okay, so that's what's going on there. And what I want to call your attention to, though, is note that the region here is US West 1. If we look at our policies for AWS, we have one that's restricting instance type, and we have one that's restricting the region. If we look at the one restricting region, what we're going to see is that I'm restricting the region based on the availability zones. I'm basically saying that the availability zone has to be US East-1 and then some letter, right? Those are all the availability zones in that region. So I'm saying this has to effectively be in US East 1. Okay, well, let's actually try some provisioning there and let's see what happens. Variables, by the way, again, I have my AWS keys here. And I should mention, by the way, you see all these cases where I'm having the credentials that are hidden. One thing we have as well with Terraform is we do have a vault provider. So I mentioned in one of the first few slides, vault as securing infrastructure. One of the things you can do with Terraform is store all your credentials in vault and then get the credentials from vault instead of storing them here. So using the Terraform vault provider, you could have your credentials stored in vault and get them from vault. So that's my little advertisement for vault here. Okay, so we have our variables. Let's go ahead and queue this. So we're going to wait for that to queue. And while we're waiting, we can come here and refresh what we have going on in Azure. And notice that we do now have a VM. Here's our VM that was created. So there's our demo TFE for Terraform Enterprise VM. So that was provisioned. Okay, so if I refresh here, now I'm in my AWS console. I don't have anything yet. Oh, well, of course, I haven't done apply. Now I have an error, right? And in fact, what we see down here is organization policies hard failed. Well, why is that? Of course, it's because of the region, right? We're going to see up top here that the actual policy that failed was restrict AWS region, which is hard mandatory. And that's because of the availability zones. Now, because this is hard mandatory, I'm not given the option down here of overriding, right? I can leave a comment, but I can't override. So what are we going to do about this? I have to go fix my Terraform code over in GitHub. So notice I'm on my dev branch. I'm going to fix it in dev first. Let's go change this to US East 1. And I think we're good on time. US East 1. And I'm going to down here say changing region to US East 1. And let's commit that. Now, before I do that, if I just come back here, let's just look at the current run. Notice current run plan errored a minute ago. All right, let's commit the changes and let's see what happens. Over here in Terraform, if I refresh, we now see a new run being done, right? This was triggered from GitHub a few seconds ago. And we see our plan being run. Our plan is going to provision some Terraform, some things into AWS. It's going to provision the AWS instance, the Ubuntu instance. And now our policies have all passed, right? So now we're good and we can go ahead and apply that. So that's going to show up in AWS pretty soon. Excuse me. So that's gonna show up in AWS. But what I want to do next is I want to then go to the prod workspace. Remember, I had a second AWS workspace. Let's go over here, and what I'm going to do is, now remember, I want to make sure that I'm provisioning the right region. What I can do here is I can do a pull request from dev into prod, right? So we're going to go into prod from dev. Notice here there are things to commit. Right, this is my most recent commit that I just did. And I can say merging dev to prod to use right region. And I can go ahead and do that create pull request. Now, when we look here and I refresh this on the current, remember I'm in the prod, I'm looking at prod. Now we see that a run is being done and it's planning. And I won't show you the plan, it's going to be the same thing as before, pretty much. Policies passed. Now it's interesting here, note that the policies have passed, but I don't get the chance to do an apply. There's no, I can submit a comment, but I can't apply. Why is that? Well, think about it. When you're committing code or when you're doing a pull request, somebody is doing a pull request, but that pull request has to be approved, right? It has to be merged. So here we can see, by the way, that checks were done against Terraform. So we see all the checks that passed. We can actually see here there were checks done against Terraform. So that's a two-way integration, in terms of that integration between GitHub and Terraform Enterprise. But now I can actually merge the pull request. So I'll merge the pull request, and I'm going to confirm it. And if I go back to Terraform Enterprise, we now are going to see, if I refresh this, that now a new run is being done. And we see the merge pull request number 4 from merging dev to prod to use right region, right? And our policy check is being done. It's going to pass. And this time we actually now do have the confirm and apply button. So I'll say apply to prod, confirm and apply. And finally over here in the AWS console, if I refresh, notice I have my demo dev. This is the one that I first provisioned, right? This one we can see, I don't know if we'll have a timeline as to when it was provisioned, but there's probably January 12th, right? That was launched January 12th at 10:35, a few minutes ago. And if we refresh again, there we have our demo prod, right? So I just provisioned my prod. It's in the same area, right? But demo prod. So it's still, well, it's done, right? And we see the output as well, right? There's the result of the apply. And one last thing maybe I'll show you since we're here is notice the state, right? We can go look at the state and we can see what the state was for the most recent. And we can see, in fact, the history as well, because I can go in here and I can go over to my state screen and I can see, you know, state from a few seconds ago, a minute ago, 20 hours ago. Like here we see everything in red because I had destroyed the infrastructure, right? I destroyed everything, so it was kind of canceled. It was, you know, crossed out and colored red. So that's another thing you have in Terraform Enterprise is the state management. So to summarize what I did here today is I provisioned VMs into Google, Azure, and AWS. I showed you in the case of Azure of using a module, a compute module from the public Terraform module registry. I also showed you how the Sentinel policies were checking things like instance types and sizes and publishers and regions. You could also do things, for instance, like verifying that the IP range of, let's say, a subnet IP that in your firewall rules and your security groups for AWS that you don't allow access from 0.0.0.0.0, right? You might want to prevent that. So those are some of the things. So that's essentially what I showed you. And I also showed you the promotion or the interaction of a VCS system, in this case, GitHub, with Terraform Enterprise, in particular when we did a commit from GitHub and also when I did a pull request and a merge, right? We saw those interactions. And we also talked earlier about the teams and, you know, the teams and the way we control who can do what within Terraform through teams and organizations. And you can, by the way, you can define multiple organizations. You can see here I have multiple organizations there. Okay, I think that's it. So with that, I'm going to hand things off to John Benson, who will now start to answer some of the questions that you've hopefully been submitting. Thank you very much, and I'll stop sharing my screen as well. All right, John, you're up, if you're not muted.
Hi, everyone. I've been trying to answer some of these in line here. So if you've been getting the messages through the chat, you can look for some of the links and documentation. Turn on my video here. There we go. Hi, everyone. And so I'll continue to look through those lists, the list here. Some of the ones that I did answer that you can look through the chat for are, what are the resources do you have available to get an intro to Terraform and set up a test case? For that, the links I provided were the getting started guide that we have on the Terraform.io website. And what that has is a number of examples that are easy to follow for getting started, provisioning just a simple EC2 instance like Roger was showing in AWS, in Azure, and GCP, wherever you might want to. And then there's also some more involved demos in the examples section, which is on the left bar there. I provided the link in the chat as well. And so the Terraform.io website is generally the best place. It's where we try and centralize that information. There's also a guide section. So if you go to Terraform.io, on the top menu bar there's a guide section where we're going to continue to add more and more examples of common use cases that might be a little bit more involved, but allow you to see how you can use Terraform in more advanced ways, as well as how to follow general best practices. And so, for instance, just looking through some of them, we have a very detailed section of Terraform recommended best practices, which go through how to set up your workspaces, how to structure your GitHub repositories, kind of evolving from, you know, a smaller infrastructure to one where there's many different operators, there's many different producers of that infrastructure as well as consumers. So for instance, you might have a networking team that builds a lot of networking resources, and you want that in one GitHub repository so you can manage the ACLs effectively and ensure that it's only your networking team that's managing that infrastructure. But of course, you're going to have people who want to provision resources within that networking infrastructure, and in which case you might have a separate GitHub repository with your ECS resources or your Kubernetes resources or your Nomad resources, so that your developers can leverage those pass type resources to submit jobs and deploy their workloads maybe into your networking team's infrastructure. And so it just provides overall general recommendations and best practices that are definitely good to walk through. So that's where we're going to continue to aggregate that content. You can look on terraform.io, and then there's HashiCorp.com as well, where you can see exciting new updates on new features that are both in the open source and the enterprise, as well as what's going on in the Terraform community. So that's one question. Another question that's kind of in that same vein is, see here. For what would read permissions on a workspace be used? That's a great question, in that this comes down to ACLs, and a lot of the best practices that I was just recommending was how do you separate the concerns, and how do you ensure that the people have the right access to the right infrastructure. Now that it's all code, we can manage this like we've managed application code in the past. And for Terraform workspaces, you can kind of think you're mapping a workspace to a repository, where a repository is some Terraform templates that you use to provision infrastructure. So you only want the right people to have permissions to modify that code, because it will inevitably modify your infrastructure once it runs through Terraform. What read permissions do is allow you to read the outputs of that workspace, and there's more than outputs there, as Terraform Enterprise has an API. So you have the read access to what the workspace exposes through its API. And so a scenario that I just walked through was you have a networking team that has a workspace, and that's tied to a GitHub repository that has networking resources. So they have a VPC, let's say private subnets, public subnets, internet gateways, etc. And they've stood up that infrastructure, and now they want to expose it to other people across the organization. So you might have one development team who has a Kubernetes cluster. You have another development team that has a Nomad cluster. You have a separate development team that has an ECS cluster. These are all resources that they're then wanting to deploy into the networking team's infrastructure, but they need to know where that is, what that is. There's VPC IDs, private subnet IDs, etc., that the networking team will want to expose. And so what we can do is use the read permissions on the Terraform Enterprise Workspace to ensure that the consumers of that networking infrastructure is, or that the consumers have access to that networking infrastructure, where I can stand up my ECS resource and to do, or whatever, maybe it's an EC2 instance that I want to run my application on, I can then read from the networking team's workspace what the private subnet IDs are that I'm going to launch that EC2 instance or auto scaling group and launch configuration into, so that I don't need to know the makeup of a VPC or the private subnet or all the firewalls that the networking team has, you know, the general best practices in their mind for. I just need to know where it is, and so I can do it in an API-like interface where I read the Terraform remote state resource by providing my token that has read access to that workspace. And so you can start to separate out your infrastructure. And if you think about microservices, you can think about it like micro infrastructures, where rather than having all of my infrastructure code for networking and all the different teams in one repository or in one place, where it would be a nightmare to manage access and ensure that no one breaks stuff, you can start to separate that code or Terraform templates out into separate repositories, separate workspaces, but still allow them to work together through Terraform remote state. And so I'm going to find the question there, because there is the Terraform remote state resource, which I've got a link to. It sounds like we're getting a good amount of questions coming in, so I'll move on. There we go. Send to all. All right. Is the source code for this demo available for anyone to explore Terraform and build upon what's constructed? Yes, what we're going to do is send that out in a follow-up email. So the resources that Roger put together, as well as a number of other resources that we're continuing to work on, will be available, and we'll follow up to the group shortly after, so that you can see those. Let's see. Due to audio issues. All right, can you integrate with Microsoft Active Directory for the team member logins? So what Terraform Enterprise exposes is a SAML integration, and we recently landed that in Terraform Enterprise, and we're excited about it because it does provide these Microsoft Active Directory team member login type login scenarios or authentication scenarios. So what I'll do here is post the link to the SAML documentation in Terraform Enterprise, and you can go look at that, but it is available. See, I'm assuming that the Atlas GUI is part of the Terraform Enterprise version. Is that true of the GitHub connection? Does the open source version limit one to working only on the local dev environment? So this is a good question. I'll answer the first one. So Atlas, as a bit of a background for those that are familiar with Atlas, Atlas was the initial incarnation of Terraform Enterprise, though it included a number of other enterprise products in a SaaS type offering. Terraform, what we did was break those out into their own enterprise tools to make it easier to consume whatever tool you're actually using. So you're interested in Terraform Enterprise, you don't necessarily want Vault Enterprise and Nomad Enterprise and these other tools that are solving separate use cases. So what we did was convert that to Terraform Enterprise. So we didn't throw anything away. It was just hyper-focused on Terraform Enterprise, which is what it's named now. There's a SaaS version and a private version. The SaaS version is, if you go to atlas.hashicorp.com, that's what you're going to see. That's an application that runs, and it has an API. It's running Terraform, the open source binary, for you, but it gives you a lot of collaboration features and governance features on top of what you would get with just the Terraform open source binary. Now, obviously, many companies aren't willing to run their infrastructure from a SaaS, not on their premises. And so what we do have is a private version of Terraform Enterprise, which you can run in your own AWS private VPC. And we're just getting close to releasing an installer where it can run anywhere. So it can run in Azure, it can run in VMware, it can run in whatever location, as long as you provide the compute, network, and storage resources that it will require. So that's something that is in the kitchen, and we're about to release it, and excited about it because it gives you that Terraform Enterprise collaboration and governance features wherever your infrastructure might be, in a private or public scenario. All right, if I was interested in the on-prem Terraform product, how could I use Sentinel as well? Is it a separately licensed module of the Terraform server? So great question. Sentinel is actually integrated into Terraform Enterprise. And what you saw with what Roger was doing is you can create these Sentinel policies as code and enter them into your Terraform Enterprise organization. Eventually, it'll get more granular where you can do policies per workspace and that sort of stuff. Right now, it's an organizational-wide set of policies that you can ensure every workspace is running through. Now, what what that means is any Terraform plan or Terraform apply, you can have it be required to pass through a Sentinel policy. And those Sentinel policies can be whatever you want. You can import any resources that you want to. In this case, what we've made available are the Terraform plan and the Terraform apply outputs. And so you can start to ensure that the simulated state or the state file that you want or that you deem as in line with your organization's policy, every workspace is going through that. And so it's not separately licensed. It's a part of the Terraform Enterprise Premium SKU. So there's Terraform Open Source, then there's Terraform Pro, which is the collaboration features, and then Terraform Premium, which is the Sentinel features. And what I'll do here is link the Terraform Enterprise site. Give me one moment to that question, because that will provide, actually, here's all the features. There we go. So I'm going to paste that there to that question. If you have any more questions about that, don't hesitate to follow up to the link or the email that Amanda will send out, and we can give you more details around how the Sentinel integration can work for you. Let's see. Oh, the other question about the Atlas GUI was is that true of the GitHub connection? So yeah, the GitHub connection works in both the SaaS as well as the private. There's some restrictions around if you're running GitHub Enterprise that you may not want it open to the world, in which case the private might make more sense because you don't have to expose your GitHub Enterprise instance to the public internet, in which you would generally have to if you had the SaaS version working. So if it's GitHub Enterprise, a lot of times companies will use the Terraform Enterprise private install. But if you're just playing around with it, the SaaS and public GitHub is a great way to get started and kick the tires. Let's see, does the open source version limit one to working only on the local dev environment? No, you can use, many people use open source to manage very large scale infrastructures. Where Terraform Enterprise comes into play is when you start to require collaboration features. This is common when you may bring Terraform Enterprise into or Terraform open source into your company. You start managing your resources, and then your team member goes, "Hey, what's that?" This is a pretty exciting way to sanely manage our growing growing complexity of the infrastructure. And so what Terraform Enterprise helps you solve for is those team scenarios where you don't want to step on each other's feet. You want to manage the ACLs appropriately. You want to have a good common workflow, centralized workflow for where you store very sensitive variables like AWS credentials, and GCP credentials, and Azure credentials, essentially the keys to the castle. You want to store those in tools like Vault, which were designed for that sensitive information. The other piece there is the governance model. When you need things like Sentinel, policy as code, when you're rolling this out to very large scale companies, like you saw some of the ones that Roger had mentioned, you start to require those things. So you can use open source as long as you want, and if it works for you, that's great, and we want you to continue to use open source for the rest of the time to manage your infrastructure. We just provide the collaboration governance features if that's what you as a company desire and don't want to build yourself. Is Sentinel Enterprise only? Yes. Is there a way to bulk import the state of current cloud subscriptions into Terraform state? Unfortunately, no. So there's a Terraform import feature, which I'll link here, that allows you to actually do it. And this is different than a lot of other provisioning tools, is that there's no way to take what my existing infrastructure is and pull it into my new orchestration tool. And Terraform does allow you to do that. However, in its current iteration, you can only do it one resource at a time. And so the Terraform state file is what is the source of truth for all your infrastructure. So when you do a Terraform plan or a Terraform apply, it's constantly writing to that state file to ensure that the resources that are available or the resources that have been provisioned are all registered in that source of truth, and that if anything changes, that you can see that drift there. Now, what what you're able to do with the import is take existing resources and write those to the state so Terraform is aware of them. Now, moving forward, we have plans to make that better, where eventually the ideal scenario is you put in your AWS credentials and you hit go and it sucks in all the resources and maps them appropriately. However, you can be very opinionated about what your infrastructure or how your resources interact with each other through interpolation, through modules. And so we are still thinking about the best way to create those mappings for you. And so right now it's just a manual import, but you can certainly do it. And you can then design your infrastructure the way that you would if you were just creating it with Terraform to begin with, though with existing resources. Moving on. All right, how do you manage to map an already existing infrastructure that is set up across regions when using Terraform import? It only generates Terraform state, not the initial resources. Do you have the feature mapped? Okay, yeah, so I think I covered this in my last response, but yes, it only writes the state. You still have to write the parallel Terraform configuration. Otherwise, the Terraform plan, because you haven't declared it, will say, I'm going to delete this resource. And so you need to import it into the state and then write the parallel Terraform config so you end up with a clean plan. Yes, we have plans to fix that in the future. I wouldn't say it's going to happen immediately, but continue to stay tuned. And that's something that if you want to follow up to this webinar with, we'd be happy to discuss in more detail roadmap-wise. Are you now or are you planning to support BSTS as a repository? It's not currently on the near-term roadmap. That's a question we can discuss in more detail as well following up this. Is it possible to use Terraform for on-prem infrastructure? Covered that earlier. Yes, it is. Right now, it's GA in AWS, where you can run Terraform Enterprise in your own VPC. In just a few short weeks to months, I would say it'll be available anywhere. So follow up to the email that we send out, and we can give you more details on exactly when it will be publicly available. Right now, it's still in the kitchen. Difference between Terraform open source and enterprise. Good question. Roger covered some of that. Everything that was via a GUI was Terraform Enterprise. Terraform open source is just the single lightweight Go binary that pulls in all the plugins and builds the infrastructure based on what you've declared with Terraform templates. Terraform Enterprise is the application that Roger was doing his entire demo through, which was the workspaces, it was Sentinel, it was a variable management, and that whole workflow. So please follow up. There's features on the website that I had posted before. You can actually post those here or follow up. Please share this slide. We'll share those after. And I think we're just coming up at about time. Amanda, feel free to cut me off whenever we're ready. Otherwise, I'll keep going.
John, do you want to take maybe one more question?
Sure. Okay. So one last one, which is a good question, is it possible to use Terraform for on-prem infrastructure as well? So Terraform can interact with anything with an API. And so often what you see is CRUD operations on different resources that are exposed through Amazon's SDK, through Google's SDK, Azure's SDK. They're all just resources that they've exposed publicly via an API. And so that's how Terraform can interact with IaaS, PaaS, and SaaS resources all through one common workflow and one common configuration. And so that's the same for on-prem infrastructure as well, where if there's a provider available that someone's built, which there's some nice documentation on how to create those providers, as long here, I'll even link it, writing custom providers. As long as there is a provider for it, Terraform knows about it. And so a lot of our customers have private resources that just aren't publicly available. They'll write their own custom provider so that they can manage their load balancers, they can manage, whatever on-prem infrastructure that isn't necessarily a common public resource. So certainly, as long as there's an API. And with that, I will hand it over to Megan, Amanda. If there are any more questions, I know that there was a ton that were asked here. Sorry we couldn't get to them, but feel free to follow up to the email and we can ensure to get those answered at a later time.
Okay, thank you so much, John, and thank you, Roger, for doing the demo. We got a lot of great questions from the audience. Thanks, everyone, for being so engaged and asking your questions. I hope everyone enjoyed today's webinar and was able to learn more about how you can use Terraform to provision VMs to AWS, Azure, and Google Cloud. Again, thank you to everyone who joined, and big thank you to Roger and John for their time today. I also want to mention that we have training partners who offer training on HashiCorp tools where you can go even more in depth and hands-on. So if you liked what you heard today, you want to learn more, take a look at our training page at hashicorp.com/training to learn more. And finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I will also send an email to everyone who registered with the recording link, as well as those questions answered, like John mentioned. You can also keep your eyes out for the recording on Twitter. I'll post the link there as well later today, probably. So thank you, everyone. Have a great day, and we'll see you next time.